Hi everyone, welcome back to our channel. Today we are going to solve the problem number 51. This is on compensation theorem. Okay, so here what is the given question is calculate the change in current delta I if the network by using an compensation theorem when the inductive reactance already this is J40, it is increased to J35 ohms. Okay, so we asking that find that change in current delta I using compensation theorem. So how to do it is first we need to find out the total current I. Okay, so total current I is equal to, so I want this current, what is the voltage at this point, 100 at an angle of 45 degrees divided by 30 plus J40. Use your calculator and you can find this value as 2 at an angle of minus 8.13 degrees. Okay, this is our current. So if you are confused how to change it, first convert this complex form into an polar form. 50 at an angle of 53.13. If you do it, 100 by 50 is how much? 2. 2 divided at an angle of minus 8.13 is our current. Okay, so now this is the current we had find, but he's saying that the impedance has been changed in this branch. Okay, so now we need to redraw the network just by short circuiting the voltage source. Replace this voltage source with 0 and draw the original network as it is. This is 30 ohms and already the old inductance is how much, plus J40, and now add the, this is original Z, add plus delta Z. Delta Z value is how much? Already we calculated. Delta Z original is how much? Plus J40 minus J35, which is nothing but delta Z is how much? J5 ohms. Okay, so this is J5 ohms delta Z and introduce an voltage with the polarities shown here, and this voltage you are going to call it as compensating voltage. What is this magnitude of compensating voltage is original current multiplied with delta Z. So what is this delta Z? Already we have been obtained here. Original current is how much? 2 at an angle of minus 8.13 and delta Z value is how much? Plus J4. Just multiply this value, then you can get the compensating voltage. So when you do it, this you are going to get it as 2 at an angle of minus 8.13. This I can write down it as 5 at an angle 0. Just you can do the product now. When you do the product, then you're going to get 5 twos are 10 at an angle of 81.87. Okay, so this is the compensating voltage. Whenever the original source is deactivated and compensating voltage is introduced, then a change in current in the circuit is delta I. Okay, so we need to find out this delta. How to find this delta I is very simple. Okay, so directly I can find the change in current delta I is equal to. Okay, so the current is leaving, what is the leaving polarity of voltage? V compensation. Okay, V compensation divided by, so what are the resistance we have? 30 plus J40 plus J5. That's all. So just write down those values. This is 10 at an angle of 81.87 divided by 30 plus J45. Convert this A plus IB into complex form. Then it is 10 at an angle 81.87 divided by 54.08 at an angle of 62. When you write down it, then you are going to get it as 0.184 at an angle of 19.87. This is the change in current whenever the impedance is changed from J40 to J45, and that's how we have been find the change in current delta I using an compensation theorem. Very simple. Just write down the original current of the network and then introduce and compensating voltage in this branch and write down the change in impedance also, and then find out the change in current by using normal current. So here you should be very simple. Why? Because no, the change in current, everything is in one branch. It's very simple to solve. Hope you are able to understand. If you feel my explanation is good and you are able to understand the problem, please like the video and share with your friends. And if you have any doubts in this problem solving, let me know in the comment section. And if you are watching the channel for the first time, subscribe to the channel with the name KV Tulasi Ram. Thank you for watching. We'll meet in the one more problem on compensation theorem. Thank you. Yours Ram.